I'm Dongwon from SK Telecom, and this is my colleague Haemee. Today we are going to present our web service named Flow. Flow stands for Flink On Web, and it is designed in such a way that anyone can use Flink easily on web-based graphical user interface. And let's start with the motivation. We started using Flink 2 years ago when we are trying to make predictive maintenance solution. And fortunately, last year, we again had a chance to use Flink to migrate driving score service into real-time stream processing. When we looked back how we used to work, there were domain experts and the target systems and their requirements. And they want to generate something from the target systems as soon as possible, which means in real time. So when we are asked how to process real-time stream data, we recommend them to use Apache Flink. But the distance between domain experts and Apache Flink was non-negligible at all, because they are far from, or they have nothing to do with all these technologies needed to develop Flink applications. So here we come to bridge the gap between domain experts and Apache Flink. We've got requirement, domain knowledge, and data, and we designed and implemented streaming processing pipelines, and we needed to train them how to use Flink, and we need to transfer what we implemented, and we were involved in maintenance to some extent. So as you can see here, this is very inefficient. In this way, we will be able to just 1 or 2 projects per year. So, but besides mobility and energy domains, we have many interesting domains like semiconductor, telco, IoT. We want to apply Flink to. So this year, by introducing Flow, we let domain experts directly express their requirement and domain knowledge on Flow. And the most distinguishing feature of Flow is its easy-to-use graphical user interface, where users can build stream processing pipelines consisting of SQL operations. Because everyone knows SQL, and Flink will hide all the details of Flink app development. So in coming years, we are expecting much wider and faster adoption of Flink in these domains. Okay, let's see how Flow can be used to figure out the popular place exercise in its own style.
Hello everyone, I'm Haemee Park. As Dongwon mentioned, I'm going to show you a short demo. And since we have very limited time, I already recorded and captured all of my screens. So if you want to try Flow in person, please contact me or Dongwon after this presentation. Okay, now I'm going to show you a demo based on popular places scenario. I'm pretty sure all of you are very familiar with this scenario, so let me briefly describe it. Whenever a person pick up or get out of a taxi, one record is added on our Kafka stream. And each record is comprised of 3 IDs and 1 Boolean flag, which indicate if this record is generated from pickup or drop-off event, and a pair of geographic coordinates, passenger count, and of course, event time. Whenever one event happens, 1 record are added on our Kafka stream. So first thing we should do is removing some records which happened outside of New York City, since there are some records with invalid coordinates. And next, we are going to map each record into a grid cell on the map. And next, using Flink's sliding window feature, we are going to divide our Kafka stream into 10-minute length sliding window every 5 minutes. And finally, we are going to counting the number of events in each grid cell to identify the cells whose count is 10 or more as a popular place. That's all of this scenario. So now let's access to the Flow. Since Flow is a web-based service, so we can access Flow via web browser like this. And this is the first screen of Flow. First thing we should do is creating a flow. At this point, flow means a Flink application. So to create a flow, I'm going to input some general information, such as the name of this application and time attribute. And secondly, I'm going to input some information about Maven project. Since Flow support users to download automatically generated source code in a Maven project. So at this stage, users should input information about Maven project. And finally, this is an optional step. I'm going to input information about chart backend. One of Flow's key feature is data preview. And data preview is provided not only in a form of plain text table, but also in a form of graphical chart. And internally, Flows use external visualization tool to draw a graphical chart. For now, Flow supports only Elasticsearch and Kibana. So at this stage, I'm going to input information of my Elasticsearch and Kibana. That's it. We have finished create a flow, so now we can access this screen, which is the canvas of Flow. On the canvas, user can create their own stream application in a drag and drop manner. So first of all, I'm going to add Kafka source like this. And then I'd like to specify some properties about this Kafka source, such as the name of topic. And when I click Apply button, yes. And now we can see the data on this Kafka stream by click this preview button. On this screen, I'd like to fetch 1,000 records per each partition from Kafka source. And when I click Show button, yes, we can see 3,000 records are fetched from our Kafka stream, which is 1,000 records from each Kafka partition. So now I'd like to deserialize each row into 10 fields like this. Yes. And then name each column and assign the type of data on it. And when I click Apply button, yes, we can see the name of columns is appearing here. So now we can apply Flink's watermark strategy on our Kafka stream. I'd like to apply periodic bounded strategy to allow 5 millisecond latency. So when I click Apply button, yes, as you can see, when I mouse over on a row, we can check the timestamp of this record as well as watermark. I think this is very useful because Stream developers are always struggling with checking timestamp and watermark. So far, we checked our preview data on the plain text table, but sometimes it is very difficult to catch the meaning from the text table. So Flow support users to check their preview data on a graphical chart. So when you go to a chart tab, we can see Flow support two kinds of graphical charts. One is time series chart and the other is map chart. To draw a time series chart, what users should do is simply select a column to draw a chart. In this case, of course, event time. So when I click Show button, yes, we can check our preview data on the time series chart like this. And similarly, we can create map chart like this. And when I expand map chart, now we can easily detect there are some records outside of New York City. And of course, we can expand this map to look closely. So at the next stage, what we should do is filtering some records. So I'd like to add this filter operator like this, and then connect it with the previous one. After connecting these two operators, as you can see, the preview panel is divided into two parts. And upper part is regarding the previous operator, that is Kafka source, and lower part is regarding current operator. Not yet, we've finished defining our filter operator, so it's empty now. And so in order to complete our filter operator, I'd like to use UDF. And on the flow, user can easily upload jar file like this. And after uploading a jar file, flow automatically detects the Scala functions inside this jar file. In this case, there are 3 UDFs. And now I'd like to use Easy New York City function. So in order to use this UDF, what user should do is just name the instance and click the initiate button. So that's it. And now I'd like to skip the steps to initiate the other 2 functions. So when we go back to the previous screen, we can check that the 3 UDFs are appearing here. So we can define our filter condition with this UDFs like this. And when I click Save button, yes, now we can see some records are filtered out, so only 2,918 records remain. And when we check the time series chart, we can check the count at a certain point of time. And on the map, now we can find out this point is disappeared on the lower part. And next, we are going to use this select operator like this. And on the select operator, user can interactively select columns like this. As soon as user click this plus button, the column is appearing on the preview panel. And of course, user can use UDFs or SQL expression like this. And next, we are going to use Windows operator. As I said before, we are going to create sliding window. It is also very simple. After specifying some properties, like sliding window type over 10 minutes record every 5 minutes, and grouping all rows by these columns, and finally select some columns that I need. Then we can check the result here. And when we check the time series chart, we can see that all rows are aggregated into a window with the 5-minute interval. And next, we are going to use SQL query operator to filter out some records whose count is less than 10. And on the SQL operator, we can use any SQL syntax. So, of course, we can use UDFs. And when we click Save button, yes, now only 20 rows remains. So, finally, the last step is creating async. In this case, we are going to use Elasticsearch sync. And we'd like to apply 5 second work flush like this. And we finished creating our own popular places scenario application within about 10 minutes. And now we can download the automatically generated source code by clicking this download button. And when we open this downloaded file, you can check that it is a Maven project, and this is a source code inside it. And of course, we can directly run this application by clicking this run button. And only if you create some visualization on your Kibana, you can easily build this kind of real-time dashboard on your Kibana. That's all of my presentation, my demonstration. So next, Dongwon will explain the architecture of Flow.
Okay, thank you, Haemee. Let's see what's going on behind the scene. When you drag and drop Kafka source on the canvas, Flow will create a corresponding resource on our Spring-based backend. And when you complete the specification, Flow updates the Kafka source in the backend with the specification. And as the response, Kafka sources schema in preview are expected to be returned, but they are so that Flow can show you this preview table. But these resources, schema in preview, are missing now. In order for Flow to compute them, Flow relies on a set of preview loaders. First one is Kafka preview loader, and the second one is Flink preview loader. And this time we use the first one, input from our backend, output from the Kafka preview loader, output updated in our backend, and we finally return the response. Then we can show you the Kafka preview. And this is when SQL operation is added, filter, and things are pretty much the same until we need to use Flink preview loader here. This time we send down not only filter's specification, but also its parent schema in preview. And let's go down a little bit deeper to see what's going on. We entirely piggyback on Flink for schema and preview computation. So to that end, we first create a local Flink mini cluster. Then we create a stream table environment per user session. Then when we are given this input, using the parent schema in preview, we define parent table. And before defining the target table, we need to register all user-defined functions here. Then we define the target table using the specification of target operation. This case is filter operations, filtering condition. And we need to get some result locally. And then we have Kafka Flink preview loader to return preview and schema of a filter operation. In this way, we calculate the output, and they are stored on backend. And in this case, we need to return both operators, preview and schema, so that users can see the difference before and after applying the SQL operation. Okay, things are the same for the other SQL operations. And when you complete the pipeline, and when you click on the download button, then Flow send all operators spec and schema down to the project generator. Then you will have, as Haemee showed you guys, a Maven project and a Flink application. And for this particular functionality, we use Java Poet, that free marker here, to generate this Java code and Maven project. Okay, based on this strong foundation, we have implemented a few connectors, few SQL operations, and among them, we have also parent recognition operator and temporal join operator. And I attended SQL tutorial yesterday, and when Fabian tries to explain this match recognize clause, I heard a lot of sighs from audience because this match recognize clause is very complicated, but you guys can do that easily on Flow you can specify partition by field from the parent field, and you can do order by here, and you can define parent variables in this way, and you can define parent here, and you can choose aftermatch strategy. And finally, this is like select operation. You need to list up the expressions you want to have in the result table. And this is pretty much the same as the select operation. Okay, whenever you add the expression, you can see the update on the result table. Okay, and you can test different aftermatch strategies, and you will see the result here. Okay. And this is temporal join. Our operations can have multiple parent operators, and this is a temporal join, and you can configure temporal table, then you will configure append table, then the rest is like select operation. You can list up expressions you want to have in the result table in this way. And you can see the result columns are dynamically added, and they are all computed from our Flink preloader. And if you are familiar with temporal join, you can see that euro rate is changed there because they are all computed by Flink. Okay, these are what we've implemented for this year. A few connectors, operations, and UDF support. And we are going to show you preview data in different ways by interacting with Elasticsearch and Kibana. And we will generate project automatically for users. And we plan to support more connectors and operations, of course. And we plan to support job management, which is like Barbarica's platform, or Kinesis Data Analytics for Java application, so that we can run the automatically generated Maven project, and we can manage the life cycle of the job. Okay, that's it. And we spent too much time on it, so if you have any question, come to me and Haemee in person, and we will answer. Okay, thank you.